Okay, there you go. All right, again, good morning, everyone. Welcome. This is IPsec e-learning web class for today, 19th of June 2013. This is the first session that we are conducting for the day. Again, we're doing 3 sessions. Per session, we are doing it for 1 hour. And the first one is all about IPsec. So we will be covering IPsec, the basic functions. What exactly is IPsec? Why do we need it? What is the topologies? What are the what they call it? What are the different types or modes where we can implement IPsec? Now, for everyone's information, IPsec Training Unit holds e-learning sessions on a weekly basis. Now, it's done every Wednesday, and we conduct 3 web classes for the day. This is our first session. Now, this e-learning course aims to provide you with some sufficient knowledge of IPsec. So we won't be going into too much detail, but as a matter of fact, what I want to happen here is as long as you understand the basics of or the different components, because this is what makes IPsec really hard. What are the different components that work together, or what are the different protocols that are used in conjunction with the IPsec architecture? Now, I'd like to introduce myself. My name is Cheryl Hermoso. I work as a training officer for IPsec, and I've been working for them for the past couple of years now. Now, as part of the training team, we do conduct these face-to-face trainings to different economies, different members of the internet community, and as such, the topics that we cover are all internet related. And as you can see from this slide, the specialties that we do or the topics that we cover are network security, IPsec, internet resource management, DNS, and DNS security. So if any of those topics are interesting for you, go have a look at our website and register for the courses that you might be interested in. Now, just as a brief reminder, towards the end of the class, there will be a brief survey. Now, this is a feedback form that I would hope you will fill up for us, because this is very helpful so that we would know whether the topics that we've covered is sufficient enough for you, or whether there are other topics that you might be interested to be covered in the future e-learning courses. Now, with that, those are some of the housekeeping things. I'm very sorry it took a while, but with that, let's go on and dive into our topic, IPsec. This is an overview of what we'll be covering. First, we'll have a look at VPN, because IPsec is a type of VPN. It's actually a standard for VPN. And then we will go into the basics of IPsec. What are the benefits? What are the modes? We have 2. We have tunnel and transport mode. And then we will look into the IPsec architecture. The IPsec architecture consists of different components. We have security associations, or SAs. We have ISAKMP, which is just a collection or the way you handle or manage these security associations. We have Authentication Header. We have Encapsulating Security Payload, or ESP. And then towards the end, we will look into the key exchange, how they actually construct an IPsec tunnel using Internet Key Exchange. So that's what we want to cover for this class. Anything that is not within the scope, if you have questions regarding that, towards the end of the class, you may be able to do so if we have enough time. Now, if you find that I'm speaking very fast, or that sometimes maybe my audio come in choppy from your end, please do let me know. That's the way that you can communicate with me using the chat panel on your right-hand side of your screens. Now, let's start off with VPN. What is VPN? Well, I'm pretty sure you have a basic idea of what it actually is. VPN is being used a lot these days, and VPN is actually very easy to implement. If you have a home router, you can easily enable VPN. You can set up either point-to-point connections, or you can set up remote VPNs, going to, let's say, if you have a central, say a corporation, if you want to access your network, if you are traveling, you can also set up remote VPNs. Now, VPN started off in the early 90s. Around that time, networks for large organizations, if they have a central office and they have regional offices, so these organizations, these enterprises, were connected through what we call leased lines. So the VPN, or virtual private network, creates a secure tunnel over a public network. What do we mean by that? These lines are very expensive. We don't want that because it adds an extra cost for our company. Rather, we would use internet, which is like everyone is connected to the internet anyway. So rather than spending some money using leased lines, why not use this public connection, this public network? But we should still have a secure connections over that. That's how VPN protocol came to be. The tunnel is created by encrypting or maybe encapsulating our data as it is transmitted over or across the VPN network. Now, a common example or application of VPN, as I've said, is when we're establishing remote connections between offices where we allow employees to remotely connect to the office or the work network. Now, VPN establishes a secure, confidential, and authenticated communication tunnel or channel. You can say it's a channel too. Now, there are two types normally for VPN. We can either set up site-to-site VPN or we can have remote access. Now, here in this slide, you can see some VPN protocol standards that are used by VPN. PPTP, L2F, LDTP, and the last one is IPsec. Now, just a brief overview of the first three. PPTP was developed by Microsoft. It was commonly used to secure dial-up connections in the early days. It operates in the data link layer as well as the other two. They all operate in the data link layer. At the same time that they were developing PPTP, Cisco was also developing their own proprietary version. This is called L2F, or the Layer 2 Forwarding Protocol, which is basically the same as PPTP. Then, after a while, IETF created a standard which combines these two protocols, and what resulted is what we call L2TP, or Layer 2 Tunneling Protocol. Now, all these three work or operate in the data link layer. Now, the last one is IPsec. IPsec is actually the IETF open standard for VPN implementations. It operates on the network layer and it's commonly implemented on routers. You will see later on some of the benefits that we can get from implementing IPsec. Now, let's go into more detail about IPsec, which is what we want to really cover. IPsec is used to provide security on the IP layer, layer 3. Considering that all internet devices nowadays, they are engaged somehow in IP datagrams, right? In one form or another, they would use IP datagrams. So the value of security at this layer is just so obvious. IPsec can provide protection for communications that are either from one node to another node, one end to another end, one router to another router, one firewall to another firewall. You can set it up like that. There are two modes in which IPsec can operate. Either it's tunnel mode or transport mode. Okay, it's important for you to understand these two because you will see later on once you implement IPsec or deploy an IPsec setup, then you will be choosing from either one of these. The IPsec architecture combines several different components. All of them are brought together to provide this layer 3 security as we've mentioned. These components include these things. As you can see, I'm not sure if you can see my arrow there. So security associations, or SA. So I will be referring to this term as SA from now on. Authentication Header, or AH. Encapsulating Security Payload, or ESP. Okay, so that's this and this. And the last one is Internet Key Exchange, or IKE. So these are the components. IPsec in itself is an architecture. It combines all these different protocols. As you can see in the following slide, there are different RFCs, or requests for comments, or different standards for each of these components. So that's why IPsec combines all of these. Now, there is another terminology that you will be using, another component, as you may say. It's ISAKMP, or ISAKMP. It stands for the Internet Security Association and Key Management Protocol. Don't worry if this all sounds like just a listing of all the components. In the next few slides, we will be looking at each of them. Alright, so basically ISAKMP is the system that defines how your VPN server and your VPN client set up its security associations. Okay, Any questions at this point? So just a brief run through of why we need IPsec. Basically, you already know that IP is insecure. We cannot run an insecure network. IPsec, just a brief of history, IPsec was originally designed to be part of the IPv6 protocol so that it will provide security as a built-in to the IPv6 protocol. However, since it's taking a while before everyone adopts into IPv6, now they created this IPsec protocol to be added into IPv4. Now the difference between that is with IPv6 it's built in, you don't have to do extra things with that. With IPv4, it is an extra protocol that you add on your layer 3 of your TCP/IP protocol suite. Okay, so there are possible security issues, source spoofing, replay packets, you can have no data integrity or confidentiality. All of these can be addressed by IPsec. These are some of the IPsec standards that I've previously mentioned about. As I've said, each of the components of IPsec will have its own standards. So in order for you to understand these in more details, if you want to really dive into the details, you may want to look at these RFCs. RFCs are standards. They are provided for us by the IETF. It's a product of the internet community. All the computer enthusiasts, computer scientists all came in together to provide these or to come up with these standards. Okay, so RFC 4301 is the IP security architecture. So basically, it defines the overall architecture and specifies the elements that are common to both the IPAH or Authentication Header and IPESP or the Encapsulating Security Payload. Okay, so this is the basic standard, the first point of the IPsec that you might want to read onto. Okay, this is a very valuable document. Now there's another one, RFC 4302, and following here is RFC 4303. These two defines AH and defines ESP in more detail. So RFC 4302 defines an algorithm-independent mechanism for providing any exportable cryptographic authentication without having to encrypt it via V4 or V6 packets. Okay, so as you will later on learn, AH and ESP are both used for the security part. Okay, but there's a difference between these two. AH doesn't have any encryption mechanisms. Okay, we'll look more into that later on. So RFC 4303 defines an ESP. So basically, it adds encryption to your IPv4 or IPv6 packets. RFC 2408 is your ISAKMP. So what does it do? It defines all the procedures or packet formats, or maybe how you can negotiate, how you can establish, modify, or delete any security associations. Basically, how you set up communications between two endpoints using security associations. So it's a consistent framework for transferring any key authentication data between two endpoints. Okay, we'll learn more of that later on. Now, this is IKE for Internet Key Exchange, and if you want to learn more, these are additional documents for any cryptographic algorithm implementation for both ESP and AH. So that's RFC 4835. Okay, there are updates to these every now and then, so if you want to keep updated, go have a look at the RFCs. All right. What are the benefits of IPsec? Why do we really need to implement IPsec? Well, you already know why, because of security issues, but these are the, in more detail, these are the benefits of IPsec. Confidentiality, integrity, and authentication. These three are our basic goals in security. We want our data to be confidential. We want to keep it private. We want it to be available only to a limited number of people, okay, which they should belong to, let's say, a certain access list before that certain person or a document or system or maybe a process can have access to our data. So that's what we mean by confidentiality in general. So with IPsec, we can achieve that. We can provide confidentiality by encrypting any data or any information. If, let's say, there's a third party that intercepts our encrypted data, with confidentiality, it is sure that he won't be able to interpret this information. Okay? Integrity is, as its name implies, we want to keep the integrity of our information. We don't want our data to be modified in transit. For example, we have routers at each end of a tunnel. We can sort of create checksum or do checksum. They can calculate a checksum value or hash value so that they can determine whether the data that is transmitted from, say, the source is also the same once it is received on the destination end. Okay, so these checksum values ensures that our information have not been altered when it is transited from the source going to its destination. So that is integrity. The last one is authentication. So basically, this verifies the party that wants to access our information. So if I want to have access to the system or to that data, I have to identify myself. I have to tell them that I am who I claim to be. I will support it with, let's say, usernames, passwords, maybe OTPs or one-time passwords, maybe even biometrics, pre-shared keys, maybe even signed digital certificates. Okay, so those things can be done within IPsec. IPsec, I have to say, is not only attractive VPN technology because of these security enhancements. IPsec also scales to a wide range of networks. It operates on layer 3 as we have established in the previous slides. So at layer 3, it is now transparent to applications. Okay, IPsec is transparent to applications. Therefore, these applications don't really have to bother or don't require any sort of integrated IPsec support. That's what makes it really good because it works on your layer 3. Any questions at this point? Am I still coming in clear to everyone? Hopefully you can still catch up. It's just basically we've just scratched the surface. I've just introduced you the different components, but in the next few slides we will have a closer look at these different components. These are some of the benefits as well. Well, basically we just listed down the ones in the previous slide in more detail. So we have here data integrity and source authentication. It avoids any replay attacks. So that means if I have a VPN tunnel, if someone eavesdrop or maybe wants to do a man-in-the-middle attack, he can't do so. He can't, let's say, get the packet sent out and then make changes to it and then insert it back into the system. That's not possible because of these anti-replay protection. Okay, we have key management, so there's no way that your key will be lost, or if that happens, then there's a mechanism for these secret keys to be, say, to still work, even if it's been compromised. So that's what we mean by this. Now, just to illustrate where we're working on, this is our normal end-to-end connectivity from source to our destination. Now, where are we working at? Here. So we have routers, okay, bordering one network, let's say network A, and then another router bordering network B. So this is where our IPsec actually operates. Any questions? Okay. Now, let's look at the different IPsec modes. Well, there are two, as I've mentioned before, tunnel mode and transport mode. Okay, it's very important, as I've said, to have a clear understanding between these two. Tunnel mode IPsec, in this mode, the entire IP packet is encrypted and becomes the new data component of your new and, of course, a larger IP packet. Okay, so basically, if I can just try and draw something here, just try and remove this first. So, not sure if you can see my handwriting. So I'll just draw something on top. So basically on your layer 3, you have, let's say, this is your packet. Okay, one of that, well, this should be larger actually. So let's just assume that this is your IP packet, the packet that is coming in from your layer 4 down to layer 3. Okay, what do we have there? For the packet to be actually understood by the layer next to it, it should have a header. The header contains all the control signals, all right? So you have here, this is your IP header, okay? And then what follows? This one is your IP payload. Your IP payload consists of either your TCP header or maybe UDP header. Okay, let's just say it's a TCP header here. And this is your payload, PL. Okay, so when you're doing tunnel mode IPsec, you are encapsulating this whole thing. Okay, this whole thing now becomes your new payload. And then, because just this it cannot be interpreted properly going downstream, right? So you need to add another header. That's why it's a larger packet. The new IP packet will now have a new IP header, okay, and it will also contain an IPsec header. So what you have there actually is, this one is your IPsec header, and you will have another here which is your new IP header. That is what happens in tunnel mode IPsec. Okay, so if you look into the RFC, when the description for tunnel mode IPsec there is, it encapsulates the entire packet. As a result, the encapsulated packet now has a new header, and this new header will have its own source and destination IP addresses, same as the information reflected before in the old IP header. Okay, and then this one, this mode is actually quite useful. Okay, if you are implementing point-to-point or site-to-site VPN. Okay, this new header, you have a new source and destination in your header. Okay, so because of that, it's actually frequently used in point-to-point or site-to-site VPN. Right? So that's its normal purpose or use. Now the other one is transport mode. In transport mode, the IPsec header is inserted into the IP packet. So in this mode, you don't have a new packet created. No new packet is created. You just insert the IP header somewhere in between. So if I want to make a drawing somewhere here, so basically again, this is your IP header, okay? And then you have here your IP payload. So you will just insert something here, which is your IPsec header. So what you will have at the end is, you have your IP header, okay? You have your IPsec header, okay? And then you have here your IP payload. All right? So that's what you will get. Now, where do we use transport mode? Now, transport mode is frequently used for remote access VPNs, where let's say you have a PC or computer or a device running with a VPN client software, then you want to connect to another VPN termination device, which is maybe in your headquarters or maybe in your central office. So that's the main use of a transport mode IPsec. Any questions? I actually have a drawing here, so maybe I shouldn't have bothered drawing in the other slide, but basically this is an illustration of what your packet will look like. So without IPsec, you'll normally have your IP header, and this is your payload. Now with transport mode IPsec, what we have said before is that you will only insert the IPsec header in between your IP header and your IP payload. So this is your IPsec header. It's in between your IP header and the rest of your IP packet, which is your payload. Right? Now in tunnel mode IPsec, we have to create a new IP header. So this whole thing will now become the payload, which is this whole thing, and we will insert the IPsec header, which is this, and then we will add or create a new IP header. Any questions? Alright, so now let's look at the different components of our IPsec architecture. It consists of these many protocols. We have SAs, we have AH, we have ESP, we have IKE. Now, if you want to like say distinguish between these three, I think it's best to say group them together. AH and ESP are used for security, so they are security protocols. And then when you want to establish your actual IPsec tunnel, we will be using this last one, IKE, or the Internet Key Exchange. Okay, let's have a look at these components in more detail. First up is security associations. Now, security associations is used or needed by all the other protocols when we're creating the IPsec tunnel. So the concept of an SA is actually fundamental to IPsec. So what is an SA? It's just a collection of different attributes, different parameters that is associated with a secure connection. You'll be exchanging security associations when you're establishing a connection. So when you have an IPsec datagram, whether it's AH, whether it's ESP, when it arrives at the other interface, the question is, how does the interface know which set of parameters to use? Okay, which key, which algorithm, what policies are you going to use? Any of these hosts could have many ongoing conversations. As you will see later, actually just one tunnel will have many different SAs, so many different conversations going on. So each of these will have a different set of keys, okay, a different set of algorithms. So something must be able to direct the processing of all this. So this is specified in these security associations. All right. Now the SA is uniquely identified by three parameters. You can see here, you have your security parameters index or SPI. You have the protocol, so you have an option to choose whether you're using AH or ESP, and you have to specify destination IP address. SAs will then be stored in a database. We call this database a Security Associations Database, or SADB. Okay, hopefully you're not getting confused with all the acronyms and all the terminologies. So SAs are stored in the SADB, or the Security Associations Database. Now, a security association is unidirectional. So if you have to create your tunnel, you should have two SAs, one in each direction. So two will be required to secure a typical bidirectional communications between two endpoints. The security services that are associated with an SA can be used for AH or ESP, or it can also be used, it can only be used either AH or ESP exclusively. It cannot be used by both. Okay, so let's say you want to implement or you want to use both AH and ESP. Okay, you use the two security protocols there. So you will need two SAs for AH and then two SAs for ESP. So that's 4 security associations or in total. Okay, so when a system sends a packet that requires an IPsec protection, it actually uses a security policy. You will have a security policies database, and it will search for these selectors, okay, from this database. All right, so how do we set up a security association? Well, it can be done manually, that's possible. However, a more common and probably a more efficient way to do it is to use IKE, or the Internet Key Exchange, to create the SAs. Okay, so this is automatically. However, you have the option to do it manually as long as you can provide all the components or all the different parameters that is used by your SA. Okay, we've mentioned that. We've mentioned the three ones here, the three parameters that are unique, but there are other different parameters that has to be included there. Okay, Let's go to ISAKMP or ISAKMP. So basically, we've discussed security associations. Now, there should be a way to, say, manage these security associations, because as we've said, just one connection, one direction already uses one SA. Okay, so there are many different security associations being passed forwards and backwards within your VPN tunnel. So ISAKMP stands for the Internet Security Associations and Key Management Protocol. So if you want to read more on that, that's in RFC 2408. It is actually used for establishing security associations and cryptographic key. So basically, it defines the procedures, the packet formats in order to establish, to negotiate, maybe even to modify or delete any security association. Okay, in RFC 2408, there's a good definition of ISAKMP there. It says that ISAKMP is distinct from key exchange protocols in order to cleanly separate the details of security associations management, and also, of course, that includes key management, from the details of key exchange. Okay, so you have different protocols. Key exchange uses IKE. Okay, key management uses ISAKMP. Okay, there may be many different key exchange protocols. Each of them will have different properties. However, there is a common framework that is required for agreeing to the formats of these SA attributes, for negotiating them, and for that we use, the framework that we use is ISAKMP. Alright? So that's the purpose of ISAKMP. Alright, now for security protocols, as we've said, you either use AH or ESP. Okay? AH provides security protocols for IPsec. Now, ESP also does the same thing. So AH and ESP both offers authentication and integrity. They are typically used separately, but you have the option to use both. If both ESP and AH are applied on a packet or are used together, AH will follow ESP. Okay, so ESP has more priority over AH. Now, the main distinction between AH and ESP is actually the encryption support. Okay, ESP is far more popular in today's networks. In some cases, I think with some Cisco implementations, AH is no longer supported. AH is used for authentication. It's used to authenticate, but it's not used to encrypt IP traffic. Okay, so that's the main difference between them. Both of them are used for authentication and integrity, but AH doesn't support encryption. ESP does that part. ESP does have encryption support. Alright, so authentication will be applied to the entire packet when you use AH. I have a diagram, I have an illustration that shows that in the next slide. So basically, when you do that, all the mutable fields in your IP headers will be zeroed out, and your entire IP packet will be, authentication will be applied to your entire IP packet. So have a look at ESP just to find the difference between them. But basically, ESP uses protocol 50. It provides all that is offered by AH. I think I've already explained that in the previous slide. So what is an addition to ESP is data confidentiality. It provides encryption. It uses symmetric key encryption. So it exchanges a common key between the two endpoints in order to establish confidentiality. Now, when you use ESP, you must encrypt and authenticate per packet. So you do encryption first before you do authentication. Alright, so let's look at that in the next slide. So basically, what I want you to get from this slide is that only in ESP can you get data confidentiality. Okay, you can use either AH or ESP. You can use both. No one's stopping you to do that. In some cases, people would tend to use both AH and ESP. Now, if you prioritize ESP only, then you have all three goals met. You have authentication, you have confidentiality. okay, as part of that. If you are only using AH, it doesn't have any encryption support. All right, so what it actually will look like is something like this. So this is your resulting packet. So this is your original data, okay, your original packet. So you have your header, you have your payload here. Now, if you use AH, this again is in transport mode. What would we say when you're using transport mode? Basically, you are only inserting the IPsec header, okay? You're not creating an entire new packet. So from your original IP header and your original IP payload, you will insert your IPsec header. Now we're using AH, so this is our AH header. So this entire packet is authenticated. Okay, the entire packet will be authenticated except for some field. Those are what we call mutable fields. Those are fields that are used probably hop by hop, so you can't really encrypt or authenticate all of them. Now, when you're using ESP on the other hand, ESP adds extra encryption. Is that right? So apart from authentication, you also do encryption. So for that to happen, you need to add two things. You will add a header and a trailer. Again, this is in transport mode, so we're only inserting our ESP packet. Okay, so what happens is you split this into this, your header, and the rest of your packet. So this is still your original IP header. Okay, now you're inserting your ESP header. So this is it. Okay, you insert that and then follow that with your payload. So this is these two fields here. This two field is your payload. Now, in order to encrypt, you need to know where is the end of your data. So you'll have to add an ESP trailer. So this whole thing from your ESP header all the way to the ESP trailer, which signifies the end of your, let's say, the packet that is encrypted, all of that is encrypted. So the one in orange with color orange is actually the encrypted part of your packet. Okay, now same with the previous slide, the authenticated part is still the rest of the rest of your packet, including your ESP headers. All right, any questions? I hope that's clear enough. Now, let's look at tunnel mode. Now, this is very similar to the first two slides, of course, but just want to have a look like what happens because this is tunnel mode. We are creating a new header. So basically what happens is you have this whole thing that becomes your payload. So this is your payload. This whole thing becomes that part. And then you add an AH header. I saw someone writing in a question. Just please write your question. Let me just finish this slide, alright? So basically you add your header. So you will add your AH header and then you will add your new IP header. Simple as that. For tunnel mode, what happens is same thing as the ESP in transport mode, except that again, you are now encrypting the whole thing. Your original IP header now becomes part of your payload here. So it's part of what you will actually encrypt for the whole thing. Is ESP more secure than AH? Yes, definitely. If you want to add encryption to your packets, then you would opt for ESP. You have the option to either choose only AH. If you're not really concerned with encryption or confidentiality, then you would go for that. If you want encryption, then you would go for ESP. So those are two protocols that we use for IPsec. You can use either one of these or you can use both. When you use both, ESP will have preference over AH. That's why we said that AH will follow ESP. Okay, so that's what we basically mean by that line. So ESP will always have preference over AH. As we've said, some implementations nowadays don't even have support or are starting to remove support for AH because there is an overlap between the two. Okay, they basically do the same things. But for more protection, some people would use both of them. Is there any example where AH and ESP to be used together? Not in the slides, but implementation-wise, you can do it. You can actually do so. Any significant benefits to use both AH and ESP? Not that I can think of. I would usually just go for ESP. Again, it's a preference. It's I see some people implementing both of them, but we'll see later in the best practices. I would usually just go for ESP. Any other questions? I love taking questions, so if something comes up to your mind, please keep it coming on the chat. Once I see it, I will try my very best to answer them. Okay, so going back to the slides, I hope you already understand this. So this is just an illustration of tunnel mode. So basically, all your packet, including the header, will now become part of your payload. Therefore, it will also be encrypted, while the rest of your packet, including the headers, will also be authenticated. So the disadvantage of tunnel mode over transport mode in this case is that, of course, you will have bigger packets. So in some cases, let's say your upstream providers only have limited MTU size, you might have to inform them, you might have to coordinate with them so that they will increase the MTU size so that your bigger packets will be easier, you don't result into any fragmentation. Yes, exactly, AH would use less bandwidth, that's correct. Any questions about AH and ESP? I hope we've sort of answered most of them at this point. Now, let's have a look at the Internet Key Exchange. Okay, so what follows here is the actual creation of your tunnels. So, IKE is one of the primary protocols in IPsec. It is the protocol that we use for establishing the IPsec tunnel. Okay, so IPsec uses a collection of protocols to provide its feature. One of these primary protocols is, of course, IKE. Specifically, IPsec provides both encryption and authentication within the peers, and it uses encryption keys. Periodically, these keys will change. So what IKE does is allow administrators to either manually configure these keys or to, let's say, basically modify or manage these keys. That is the purpose of an IKE. IKE will use 3 modes of operation. Okay, so it's time to think about these 3 modes because we will use these modes when establishing our tunnel. Okay, these 3 modes are main mode. Okay, I think we'll have that in the next slide here. Yep, we have main mode. Next one is aggressive mode. And the last one is quick mode. So we'll just make this very simple in the interest of time. Basically, when you say main mode, you have 3 sets or 3 exchanges of information between your IPsec peers. So when you're establishing your IPsec connection, one peer or one end, which we will call the initiator, it will send 1 or 2 or more proposals to the other end. That other end is what we call the responder. So initiator and responder. The initiator will send proposals. This proposal will include, let's say, what are the different encryption types that I support? What are the different authentication protocols that I can use? What is the key lifetimes that I can offer? Additionally, the proposal can also indicate whether this initiator has support or can use what we call perfect forward secrecy or PFS. PFS ensures that a session key will remain secure even if, let's say, one of the private keys that's used to derive the session key becomes compromised. So you still have secure connection whether that secret key has been compromised. So that's the purpose of a PFS. So in addition to the other components or the other, say, parameters, it can also establish or say whether he's going to use PFS. Now, the 3 main mode exchanges can be summarized as follows. I think I have this in the next slide. Probably don't. Okay, we'll just get back to this first, and then we'll go to the different key exchanges in more detail in later on site. Basically, there will be 3 exchanges as I've said. First exchange, that means 2 sets of security associations already, right? Because you have to go from initiator to responder, then the responder has to reply. So the responder will select a proposal, okay, that it received from the initiator. That's exchange number 1. Exchange number 2 is Diffie-Hellman. Okay, Diffie-Hellman is a type of an asymmetric key cryptography. So basically, we will use Diffie-Hellman here. It will be used to securely establish a shared secret key over the unsecured media. Okay, so the exchange of secret key between your 2 endpoints is still secure because you're using an asymmetric key cryptography there. Exchange number 3 is when your ISAKMP session is established. This secure session is then used to negotiate an IPsec session. So essentially, you will have 2 phases. Okay, first phase is what we normally would call the ISAKMP SA or the ISAKMP policy. The second phase is the IPsec policy, ISAKMP SA, or the IPsec session. Okay, so main mode is mainly used for the first phase. The other mode of IKE is what we call aggressive mode. Now, aggressive mode is also used during phase 1. Okay, aggressive mode does the same thing as main mode, but basically it tries to achieve that easier and faster. So it quickly achieves that by exchanging only 3 packets. So with the previous one, with main mode, he essentially uses 6 packets, right? 6 exchanges. Okay? With aggressive mode, you only use half of that, which is 3. So the initiator sends the first packet. It contains all the information and parameters that we've mentioned earlier to establish the security association. Then the second packet will be from the responder. Responder sends a second packet containing the security parameters that it selected from the options or from the proposals given by the responder. So that's your second packet. And the third and final packet is when it's sent by the initiator. It finalizes all these authentication. It establishes the ISAKMP session. Okay? So I hope you understand those 2. Again, we use them for phase 1, which is the establishment of your ISAKMP tunnel or the exchange of ISAKMP policy. The last mode is quick mode, which is basically it negotiates the parameters, or when we say parameters, we meant the security associations for the IPsec session. So from that definition, you know that quick mode is used for the second phase of establishing our IPsec tunnel. Okay? Any questions? So this is how we build a connection using IPsec. So first, phase 1, we establish a secure channel. We use the ISAKMP sessions. We use either aggressive mode or main mode to exchange this information. We authenticate the identities using secret keys or maybe even certificates. Now on phase 2, that is when we establish a secure channel between these 2 endpoints for the intention of transmitting an IPsec enabled or IPsec secured transmission of data. That's what we call the IPsec SA. Any questions? So just to clarify that again, IPsec, phase 1 goal. Our goal for phase 1, which is your ISAKMP SA, is to establish a secure channel between your 2 endpoints. Okay? So this channel provides us with security features like say data integrity, data confidentiality, protection against any replay attacks, source authentication, all of that. The reason behind that, or the idea behind that, is that each application that will be using this tunnel will have their own different security requirements. Okay? They all need to negotiate policies first and exchange keys. So that's what we're trying to do with phase 1. So it provides the basic security features and then allows the application to establish any custom sessions afterwards. Now for phase 2, our goal is to establish these custom secure channels between our endpoints. Okay, so each endpoint will now be identified by their IP address, their port number, or maybe their packet size, and then we use quick mode, okay, to establish this. You can have multiple quick mode exchanges, so it can be multiplexed between these exchanges as well. You generate the security associations for these two endpoints, and then you can use secure channels. You use actually the secure channel established in phase 1. So once you have your channel for phase 1, all of the exchanges going on for phase 2 uses this secure channel. So it's already secure. Any questions? So this is the illustration for that. So you have these two endpoints, this and this. So first phase, IKE phase 1, this is the first exchange. You will establish a secure communications tunnel. For phase 2, that is when you establish your IPsec tunnel, and that's when you will exchange traffic between them. Okay, I think I've pretty much discussed that. This is what happens in phase 1. So this is the illustration for that phase. These are the 6 messages that are being transported back and forth between your initiator and responder. Again, 3 exchanges, exchange 1, exchange 2, and exchange 3. This last one is already encrypted because you've already used an asymmetric key cryptography to secure any exchanges. So this is when you exchange symmetric keys or shared keys. Okay, again, it's already secure. Phase 1 can still use the aggressive mode, which uses 3, not 6 messages to establish the same thing. And then phase 2 is quick mode, where you actually establish what you call your IPsec security associations. Okay, with phase 2, this is the illustration of what happens. 3 exchanges. Message 1 is for authentication, okay, or sending proposals. Message 2 is accepting these proposals. Message 3 is to verify that the initiator accepts these security associations and finally create the secure IPsec tunnel. Any questions? So just to end this class, basically these are some of the IPsec best practices. We did not include any vendor-specific configurations in this class because we try to be vendor neutral as much as possible. So these are some of the IPsec best practices that you might want to consider. So some of you asked between AH and ESP. So if you have or you can support ESP or you have the processing power and everything, use IPsec that provides integrity in addition to encryption. So that means use the ESP option. Okay, or use ESP plus AH if you want that. Next, use strong encryption. Now, part of the security associations that you negotiate, these parameters will include the encryption types or the encryption algorithms that you want to use for that tunnel. So you have the option to use DES, 3DES, AES. So use the ones that you think is the best. So AES is the current standard, but depends on, let's say, the Xure equipment has support for that, or has they enough, let's say, processing power to support that. Now, I would normally consider SHA as as a better hashing algorithm over MD5, but it's up to you. You can either use SHA, maybe SHA 256, or whatnot. It's all up to you, but use the ones that you think is a more secure, okay, or harder to crack algorithms. Then you can use PFS. I've already mentioned what PFS is, so perfect forward secrecy. So you have the option to do that. If you have, say, highly sensitive data that you're transmitting between your endpoints in your VPN, then you might want to implement this. Any questions? So that's the end of the class. I really hope that you got something from this class. We don't have extra time to discuss them in more detail, but I do hope that you got the idea, or got at least understood how to establish IPsec tunnels using the different components, using AH, ESP, and what's the use of the IKE for key exchange and ISAKMP for key management. I hope that is clear for you at this point. I do also hope that, say, the idea of the two different modes, the tunnel and transport mode, is also very clear, and the different modes of IKE, say main mode, aggressive mode, and quick mode. So hopefully those are clear for you. Now, if you have further questions, please write them down on the chat. Meanwhile, I'll just go and write the link to our feedback form. So basically, if you think that this has been a useful class for you, please let me just type that down. 0619. Please go and check the feedback form and answer this for me. So there's the link, so you just have to click on that. Now, if you want a copy of the slide handouts, it's also available after you've completed the feedback form. So once you've done that, you will automatically be redirected to the FTP page, where you can download a PDF copy of these slides. So if there are no more questions, I'd like to thank you very much for your time. If you have questions with regards to your resources, if you are an APNIC member, then by all means go check with our help desk chat. They're open from 9 a.m. till 9 p.m. So you have all the time to communicate with them, either via chat, via a phone, or send them an email, or go chat with them live using our help desk chat. So that's about it for me. Again, thank you very much for your time and for your attention. And I do hope to see you again in our next e-learning session.